Hey folks, welcome back. So today we are solving a very interesting interval based problem from Leetcode, the reschedule meeting for maximum free time. And this is the second version of this problem. So first version of problem was study problem and we have already solved this problem. So you can go and watch where I have already uploaded two videos. The first is the beginning of the explanation that I have done and another the optimized video. So you can see the optimized video, right? And you can see the modified video where we have talked about a lot of things and I have gone through the concept, dry run and everything. So in this video, we are going to understand this problem, the part, not say the part, it's version 2 of this problem, how to reschedule the meeting for maximum free time. So let's learn the logic in step by step and we'll make sure you understand fully what's going on here. Okay. So the question is saying that you are given an event that runs from 0 to event time. So as you can see, we have given this event time and it starts from 0 to the event time, correct? Can we say that? And inside this event, we already have some non-overlapping meetings. As you can see, the meeting M0 we can say and M1. So these are non-overlapping meetings. Okay, so each with have a start and we have end, as start and end. Can we say that? We have this. So now we are allowed to reschedule one meeting, just one, and the idea is to maximize the longest gap where there are no meetings. That's your free time. Okay, so if we will understand this example, right? So let's say we have given the event time we have given is 5, start time is 1 to 3 and end time we have given is 2 to 5, right? So if we'll represent, let's suppose I'll write 0 to 1 and 2, 3, 4 and 5. So this is the timelines we have given, right? But we can say this is timelines because the event time is 5. So we'll start from 0, right? We can say 0, 1, 2, 3, 4 and 5. So these are the timelines, right? Now we can say what are the where are the meetings are there, right? Let's understand the meetings we have is between 1 and 2, right? Very first is start is at 1, start at 1 and ends at where? At 2. So this is the very first meeting we have. Okay, that is called, let's suppose call M0. Okay, another starts at 3 and ends at 5. So we can say start at 3 and ends at 5. Okay, means this part and these parts are occupied, right, with the meetings. And we say that means these timelines are occupied due to the meetings and this is called M1, right? So what are the free times we have available in this, right? So free times we have is 0 to 1, then we have 2 to 3 is the free time. Can we say that this is called the free time? Free one unit is here and another one unit is here. So total unit is 2 unit we have is free time on this timeline. So can we say that we have these two meetings we have, right? We have these two meetings, one from 1 to 2 and another from 3 to 5. So the gaps here are from 0 to 1, right? That's 1 unit of free time and another is from 2 to 3, again having 1 units, right? So can we do better here or not? Means can we do better, means can we reschedule this? Can we try for the rescheduling? Yes, right, we can do. So let's try to move the first meeting, we can say 1 2 to 0 1. Can we move this? So let's go with this, give me 1 second. So let's suppose we have given these meetings, right? And if I want to move this meeting from where, let's call from here to here. Can we move it? So it will look like how? Let's understand. So next meeting is from 0 to 1, right? And 2 is here, then we have 3 is here, then we have 4 is here, and then we have 5. Can we say that? We can say that, right? So the meeting that we have chosen is now M1 will start from 0 and ends at 1. So M0 is here, means we have moved this meeting from 1 to 0 1, right? So the new timeline look like this. So next we have another meeting is at 3 to 5, right? And this is happening after rescheduling. Can we say that after reschedule the meeting will look like this one, right? Can we say, aha, now the free time for the 1 and 3, what are the free time now? This is the free time. From here to here is free time, right? Means 1 to 3 we can say we have a free time, right? And that is having how many unit? 2 unit. 1 unit is at here at this point and 1 unit as here, so 2 unit, right? And that's the best we can do, right? And that is why our answer is coming 2. Can we say that? We can say that, right? So what are the rules we have in the reschedule, right? So let's understand the things that we have given, right? So you can only move only one meeting. There this time in study videos, right, we have seen there was one K was also given, right? But here K is not given, right? Means you can only move one meeting. Whatever the number of meetings you have given with respect to start time and end time, you can find the number of meetings, right? But you can only move only one meetings. You cannot change its duration. It must remain inside the event, right? And it must not overlap with other. You want the maximize continuous free time, right? But you have to think that you cannot change the duration. You can move only one meeting, right? Because this time K is not given and it must remain inside the given timeline, right? In the you can say in the event, it should be in the event time. You cannot overlap, you cannot go outside the event time. You should must put in the your meeting should be inside the event only, right? Okay, and it should not overlap. The 2 meetings should not overlap. And we want to maximize the continuous free time, and we can see we have done here, right? So can we say that how do we solve this efficiently, right? So if we could try brute force, we can say if we test every meeting that is given, right, every meeting that we have given, right, in the very possible ways, the possible positions, right, in every meeting. So that case with, let's suppose it have 1 lakh, let's suppose 10 lakh and 1 lakh, let's suppose up to 10 lakh meetings we have, right? That's will be too slow. That is not actually happening 10,000 meeting in a given thing, but just assume that this is we have given in the problem, right? There is not, this is not real time, but let's suppose as per the constraint we have given, if we'll take 1 lakh, right meeting, that will be too slow, right? And so there is a very clever part. Let's understand what. So what we will do, give me 1 second. Okay, so what we will do, very first we will pre-compute the gaps. Means we can scan the timeline. We will scan this timeline from where? From left to right. Okay, and we'll do checking if any meetings can fit in the previous before that, as we have done from here, we have done from here to here, right? Previous side, right? So we'll keep checking if any meeting can fit in the previous gap, and then we can scan from right to left this way, right? And we'll keep checking if it can fit later. Okay, if a meeting is you can say small enough to fit into the gap, let's suppose this was 1 unit, so this is also unit, so this can be fit, right? So we'll mark it as a movable and we'll say this is movable. Can we say that we can move it? We can say mark it as movable, right? Then in the next step, what we should do, we should find the free time. Means we can find what if we remove this meeting. If we'll remove this meeting, what would be the free time between its neighbor? So if you'll remove it and you will put it here, right? And if it's not removable, we can find the time excluding its duration. We can say we will exclude that. Let's suppose for the meeting we will not move in that, and then we'll check that. So it will call excluding its duration, right? Will take a for loop, right? That will take int I is 0, right? And we have t1, let's suppose call at 0, and t2 we have same at 0. So t1 and t2 is there. Another will take what? I should be less than n and I plus plus. So this will be our loop. So in the very first, what we will do, we'll take a condition and we'll check if duration at I is less than t1, means this meeting is movable, right? And so we'll put onto the queue at I. So we will mark this as a true. This meeting will mark this. We can move this. We can move this meeting, and so we'll mark it, right? So this queue is this. We will mark this. We will mark in the queue, and this queue is which means we are meetings are movable. It means this duration is small enough to fit in the, you can say, in the some existing free time, right? So before or after, right? So let's suppose now what we can say, let's call it t1 again, and we'll say find the max. What is the max? But we have t1 we have, and we'll say gap before. What is the gap before? There can be anything, right? So gap before at I, right? What we have. So like that we have to find the t, right? Similarly, another condition will make, and we'll check if duration at n minus I, right? N minus 1, right? I'll explain what. If it is less than equal to what? T2. If it is less than equal to T2, it means we will put what? Q at n minus I minus 1, and we'll mark it as a true, right? And similarly, we'll find t2 equal to, we'll find the max, and we'll pass t2 and the gap after what? I. Before I, gap before I, and after I. Okay. So what is our purpose? Our purpose is to mark in the array, you can say, in the queue, right? Queue at I, we can say, means the meetings are movable, and mark it as a true. Okay. So we can also find what is the duration. So their duration is small enough to fit in the existing free time, right? Before or after. Can we say that? And so we'll say, we will check with the gap before I. Okay, means we want to track this t1, we want to track the maximum gap before the current one, right? So we'll go left to right. So this time we'll go what? Left to right. Can we say that? So we'll go, when we'll go left to right, we'll use this one. Okay. Similarly, we'll track t2 here. Okay, and this t2 will track the maximum gap after the current meeting, right? So we'll go this time right to left, as we have discussed. Okay, so let's understand. Let's suppose we'll take I equal to 0, t will take equal to 1, and let's call it a 0 also, 0, and t2 will also call 0. So what we are trying to do here means we want to make I from 0 to n minus 1, correct? Means give me 1 second, you see this is little light. Okay, so we'll go from 0 to what? 0 to n minus 1. Can we say that? Means the loop index is from 0 to n minus 1, right? And this is t1, right? This t1 will start from 0, right? So this t1 is to maximize the free time seen so far from left. So we'll find the gap before the current one. Okay, and this t2 will use to maximize the free time seen so far from the right. Right, means this is from left to right, and this is from right to left, right? And we'll find the gap after the current meeting. And so we have checked with respect to this, if the duration at I is less than what? T1. So we'll mark as a Q at I. It means if the meeting is short enough to fit in the previous gap, we'll mark it as a movable. So you will say what is so you will say what is Q at I, that you are doing equal to true, right? It means the meeting I, what? Meeting I can be moved from can be moved left somewhere. Means we, as we have seen, right, it was at 1 and 2, right? So we have moved into from 1 to 0 and 1, remember, means left side. Means this is a q at I, means meeting I can be moved left somewhere, that we don't know. Okay, then we have checked this t1, right? So this t1 we are using t1 comma gap before I, means we have to find the max. We will update t1 with the gap, with the current gap before this meeting. And so if you'll want to find the gap before I, how we are going to find it? So you know the gap, we have the start time we have, right? So we'll take start time minus end time, means start time at I and end time at I, right? And we'll find for all I is greater than 0. If I is greater than 0, means we can find the gap at gap before I, right? So we'll find start time and end time, we'll find the gap. Can we say that? Then if you want to find the you can say gap before 0, let's suppose. So let's suppose gap before I, we will mark it as gap before 0, let's suppose. So in this time, gap before 0 is at 0 will pass, and here end time is nothing but we'll put 0. Can we say that? So total become what? A start at 0, right? So from here we will initialize it. Okay, so similarly we have here t2, right? We will find the gap after I, means we will update t2 with the current gap after the meeting at index n minus I minus 1, right? It means give me 1 second. So what we will do, see, we'll check if duration, right, at n minus I minus 1, this one, right, I'm talking about here. Okay, so if we will take this one, right, what we are taking here, we are taking q at n minus I minus 1, and we are saying what? True, right? It means we want to we are going into the reverse one, right? Well, we are going to, it was right to left, and this is left to right, right? Right to left, right? It means now we are checking the index n minus I minus 1. So if n is, let's suppose we have given is 5, right, and I is, let's suppose, is nothing but 0, then we'll do what? Minus 1, means we will go from 4, means 0 1 2 3 4 and 5, right? If we'll take like this, if there is n is 5, right, means 0 1 2 3 and 4, and this is your 5, right? So if we'll start from 0, let's suppose, so we were checking what? With I is greater than 0, it means this I should be 1, right? It means we'll do what? 5 let's suppose we'll 5 minus 1 minus 1, can we say that? And so it will become what? 5 minus 2 is 3, right? So what we are trying to do, we are trying to find the gaps. So we can say that gaps after I, this is gaps after I. So gap, that's all, after I, what we will find? Our start plus 1, that is this 3, and end at I. What is end at I? The let's suppose we'll call 2 this time, right? So we'll find what is the gap after I, right? So we'll find this one. So we'll say 3 minus 2 is what? 1. Can we say that? Means we have to find this one. Okay, so if, let's suppose we'll take the what we can also say, what is the event time? Event time is 5, right? So if we'll take 5 and the end time minus n minus 1, right? Let's call n is here 2, right? I consider here wrong. Okay, n is 2, right? So what we will take, n minus 2 is nothing but it was 2 to 0, let's suppose 2. So what is at 0? It is 2 here. Then we will say is 2, right? So if it's the last meeting, we'll say here we have 3. Okay, I think I did some mistake here. Let me clean this, right? And then we'll understand again. No, it should be 3. What is happening? So let's think that we have given event time, we have given, right? Start we have given, and this we have given, right? So if we'll take the initial gap, what are the initial gap? Let's call initial gaps. What is initial gaps? Initial gap start from where? It was, you can see here, right? It is 0 to 1, and we have 2 to 3, and there is, we can say here, right? Means 3 gaps we have. Gaps are 0 to 1 is 1, then we have 2 to 3, that is also 1, and then we have 5 to 5. Can we say that 1, right? So we'll say in T1, when T1 pass will take, right? It means we'll take I is what? 0. Means our duration is, what is the duration? 1, right? And we'll take T1 equal to 0, and it's not movable. Can we say that, right? Because if we'll take T1, it means how we are going to find the T1. T1 is max between 0 and start at what? 0, that I've shown you, right? And then 0. Can we say that equal to 1? So this is your nothing but we can say T1, and we are finding the gap before I, right? So gap before I, we will pass this value. Can we say that? We can say that, right? Means I was saying T1 will be our max, remember, and we pass T1, and then we pass gap before I, right? So this T1 is already, it is 0, then we have gap before I, that we will find like this. Okay, because this give me 1 second, because this gap we have find how we are finding like gap at a gap before I, we are saying, right? So it was, we are finding what? Start time at, let's suppose I we are calling, and then we are doing minus end time at I. Can we say that? Not this one. We were using this, right? Gap before I, start time at I minus end time at I, right? And so we found the gap before. So if we'll say the gap before 0, right, it will become what? A start time at 0 minus 0, and that we are seeing here, correct? Can we say that? And that is why we are taking what? At a start time at 0, we have what? We have is, here we have 1, and so this value T1 is start from where? At 1. Can we say that? We can say that, right? And we have so when we talk about I is at equal to 0, duration is 1, T1 is 0, and so we have find the T1, right? So if we'll talk about when I is, give me 1 second, when I is what? 0, what will happen? When I this time I is equal to 1, when I is 1, duration will become what? 2. Can we say that, right? And this time T1 is what? We have 1, right? We have T1 is 1, and it is also not movable. Can we say that? Now this time max is at where? At 1. This start will become at start time is 1, and end time will be at end time at 0, end time at 0. So the value will become what? 1 comma 1. Can we say that? And here we'll find some, this is our end, right? and so we will find what this is also 1. So like that we will go to find the T1 and T2, understand. But let's suppose the Q1 is coming, yeah, we can move it, right, and we'll mark it as a true. Just think, right? And so we'll say as per this example, what happened as per this example, right? And we'll say mark it as a true, right? It means only meeting 0, this was meeting 0, right? So we can move this, right? So finally we can say we'll mark the loop will mark the meetings that are rescheduled to another free gap, and we'll use only one loop to do passes, right? So there will be a left to right will go for the gap before and to find the T1, and T2 will find, right? And we'll make the from left to right is a gap before, and right to left is you can say gap after, and so it will make the solution of n time, because it will be efficient, super efficient. Okay, so let's see the code. What we need to do, we'll create a boolean, right, and we'll find the n, right, and we'll create a boolean array and we'll mark the meetings that can be moved, right. Another will take the initial gaps from both left to right, and will initialize max left at max left gap is 0 and right max is 0, right, as we know. And we'll go through two passes, right. The very first is left to right, right, and we know what we need to do. We'll go for the loop and we'll find the duration, right, and we'll check the duration. If duration is less than this, we can move it, right, we'll mark it, right, and we'll say yeah, we can move it. Similarly, we'll update the we can say max left with the current gap before this meeting, and we'll say I equal to 0, and we'll say gap from 0 to start for the first meeting, else we'll say max left gap, and we'll find the n time minus n time I minus 1, right, and you will get the max left gap, right. So either you will find if this is 0, so this is our first time start is 0, and the end time will be this for is 0, so we'll directly make a condition and we'll mark it like that, and this is for general case. Similarly, we'll go for the backward passes right to left, and we'll mark the meeting that can be moved later, right. So we'll do the reverse loop, right, and we'll start the duration. We'll find n time minus a start time, and we'll check the duration. If it is less than the gap, we'll mark it as true, and we similarly will check for the last. If I equal to at the last means update the max gap with the current gap after this meeting, and so we'll take the max right gap from how event time, and we'll just do the n time minus I, and you will get the gap from the end of the last meeting to the event time. And otherwise in all the cases we'll find the gap, right, and you know how to find start time I plus 1, and we'll get n minus n time at I, and you will get the max, right. Then we have max free time, right. So now we'll try moving, or we'll keep each meeting and we'll compute the max free time. So we'll go with the for loop, right, and we'll find the left and right. You know, we have to find the gap between the neighboring meetings also, right. So we'll check if I equal to 0, the gap is 0, otherwise we'll take the end time I minus 1, means we will start from 0, let's suppose, if it is at index 0, okay, otherwise we'll take the end time here. Similarly you will find the right, so n minus 1 you will take, or you will find the event if it is at the last, you will take the this is the event time, and that will be our right, otherwise we'll take a start plus I plus 1. We'll check if it is movable, we'll find the gap, what is the gap, right minus left, and otherwise in other cases we'll take what duration, we'll find n time minus a start, otherwise we'll update our max free time, right, right minus left minus duration, and finally we'll return the our answer. I hope you understand. If you still have any doubt, please let me know in the comment section, okay. And I will say what is the time complexity. So we are seeing here that we are using what loop, only one for loop we are using, right? And similarly here, right? So we'll take O of n time. Okay, and this is just for the boolean, right, to mark the meetings. So if you can optimize this code, right, we can take O of one time also. So think about it and let me know, because I have already done. So I'll leave it for you to try. Okay, thank you guys, thank you for watching this video, and I'll see you in the next one.